Hi, welcome to another MyMaths video. This is Pythagoras' theorem, and it's video number 300, I think, or task 300. Okay, so Pythagoras' theorem. Pythagoras basically says that if you have a right angled triangle, then the long side, if you put squares on the sides, then the area of this square is going to be the area of these two just added together. Now, we normally call these letters, so we normally say this is going to be C. We can call this one A and B, so C is always the long side. Now you've got to imagine you've got a C by C square, so the area of the C by C squared is C squared, equals, and the Pythagoras theory says it's the area of this square, which is A by A, so A squared, plus, and the area of this square is going to be B squared, so B by B gives you an area of B squared. So when you're doing Pythagoras theorem, you normally have to see, so what you have to do eventually is do a square root to get rid of this squared bit. So the questions on, or my questions on MyMaths, the first one is this right angle triangle, where I've got a 7 and a 4 and I've got an X over here. So if I point at that one, then this one, I'm just going to, I'll leave it as X, normally we'll call it C, but we would say the long one squared, so X squared, is equal to the other two squared, so 7 squared plus 4 squared, and add it together, and that's what Pythagoras says, the long one squared is equal to those two. So then I just run the numbers, so the numbers in 49 plus 16, which is 65, and then X, we get rid of this square root by doing a square root of 65, and then you just grab your calculator and put the numbers in, so square root of 65, and then you go into one decimal place, so I've got 8.06, and it runs off forever. But because I'm only going to one decimal place, that's one decimal place there, so I look at the 6, that's more than 5 or more rounds that one up, so this is going to be 8.1. So there's my first answer. Second question, I've got the right angle triangle, and it's this way around this time. I've got a 7 and a 4 and the X. So the right angle always points across to the long side, so this is the long side, so I've got X squared equals that one squared and that one squared, 7 squared plus 4 squared. That's 49 plus 16, so that's 50, 65 again. Okay, so I've got the same numbers. So X is going to equal the square root of 65. We always finish Pythagoras with a square root, and this is going to be 8.1 again, because I got that last time for the square root of 65. The third question, let's go to number 3 on my book. So just move my camera so I can see the screen. So this time I've got the right angle triangle looks like this, and I've got 3.8 and 7.5, and I'm not bothered about the decimals because it's all on the calculators anyway. So I've got Pythagoras says the one opposite the right angle, so the right angle points across, so that one, the square on that side, so X squared is equal to the sum of the other two, that one squared plus that one squared, and then I just grab the calculator. So I'm not bothered about the numbers because the calculator is going to help me out. 3.8 squared equals apparently 14.44 plus 7.5 squared is oops, I get that right, 56.25. If I add these together, so plus 14.44, then I get 70.69, and then you always finish Pythagoras, always got to remember to finish it with a square root, and then you go into one decimal place on this question, square root of that thing turns out to be 8.40, the 0 will round that up, we'll leave that alone to up 4, so that's just going to be 8.4. Okay, so fairly straightforward so far. Then we get to these questions, which are a little bit more awkward, so the bottom 3 of that 6 on the page. We've got a 9, a 5 and an X down the bottom there. Now the right angle points over to that one, remember it's the one that it points at, so it's that one squared, 9 squared, is equal to the other two squared and add together, so X squared plus the 5 squared, so these two added together. You run the numbers, so that's 81 X squared plus 25, 5 times 5 is 25. Now I've got to undo this plus 25, now I undo the plus 25 by just taking it away from 81. So that's going to be 70, no it isn't, let's just do my calculator so I don't mess up. 85 take away 25, 81 take away 25 is 56. So I get 56 is equal to X squared. And then you always finish Pythagoras with a square root, so X is equal to the square root of 56. And then you get your calculator, and that's going to be 7 and a bit, isn't it? So square root of 56 is 7.48. So the 8 rounds the 4 to a 5, so 7.5 to one decimal place. The next question I've got is this way around. So there's the right angle, I've got an X on the top, 4.3 over here, and a 9.2. Now remember, the right angle points across at the long side, and so the long side squared, so that one, 9.2 squared, is the other two squared and added together, so x squared plus 4.3 squared. Then you just run the numbers, so you got 9.2 squared equals, and that's apparently 84.64, 84.64 equals x squared plus, and 4.3 squared is 18.49. So now I have to undo this bit because I want to get the x squared out, so I need to sort that out. So I'll just take away 18.49 from that side, and that's going to give me, so what is it, 84.64, 84.64, take away 84.64, that looks right, 18.49. On the calculator, turned out to be 66.15, so there's your x squared. And then remember, you always finish Pythagoras with a square root, is a square root of 66.15, which turns out to be square root of, that answer was 8.13, 8.1 to 1 decimal place, because that 3 after the first one doesn't affect the 1, it has to be 5 or more. The last one on this page is this question, so we're going with, there's your right angle triangle. I've got 5.7, I've got 7.6, 7.6, and I've got an x there. So the right angle always points at the long one. So I'm looking at 7.6 squared is equal to x squared plus the 5.7 squared. That's Pythagoras' theorem. Get your calculator and run the numbers. So 7.6 squared is 57.76 equals x squared plus 5.7 squared is 32.49. Undo this bit, so you'll get the x squared by itself by just taking it away from 32.49. So 57.76, take away that last answer. It turned out to be 25.27 is x squared. So x is equal to the square root of 25.27, which equals square root of that answer, turns out to be 5.02, so I'm going to put 5.0 into MyMaths because it wants 1 decimal place, and even though it's a 0 I will put the 0.0 in and see if it marks it correct. So let's just put that number in, I'll check to see if that one's right. 5.0, mark it, yep, it's giving me the mark for the 5.0, I don't know whether it would give me a mark for 5 by itself. Okay, so I just thought I'd check that one. Right, page 2 on this thing, so I know that page 2 is a coordinate job. So what's happening here is I've got these points, I've got A and B, so let's say that's A and let's say B's over here. And what I know is that A is at the point 3 and B is on mine is at the point 7, so that's 7 over there. So if I was to put a right angle triangle on here, so I'll just join them up, and I'm trying to find how long A and B is, I know that the distance between these two is 4, so the length on that bit is 4. When I look it upwards, it says that that one's at the height of 2, this one's at the height of 7, so that's got a height of 5. So my right angle is here, and now I can just run Pythagoras to figure out what this one is, and I'm probably going to 1 decimal place, yep. So we call the long one C, we say the long one squared is equal to 4 squared plus 5 squared, which is 16 plus 25, which is 41, and C is a square root of 41, which turns out to be square root of 41 is 6.4 to 1 decimal place. Remember, the 0 after the 4 doesn't affect the first number after the decimal point. The second question I've got is looking like this, so we'll look something like this one. Let's move the camera down. So I've got A up here this time and B's down there, so I'll make my right angle triangle. So there's my right angle triangle, let's say. I know A starts at 1 and it goes across to 7, so that one's got a length of 6. B starts at 3, so that's 3, and it goes all the way up to 8, so this has got a height of 5. The difference between 3 and 8 is 5. So there's my right angle triangle. Point across at the long side, call it C, the long side, so C squared is the other two squared and added together. 25 plus 36 is 61, and then C is the square root of 61, and then you get your calculator finally to do the square root of 61, 7.8. Okay, or 7.81, but you round up to 7.8 because the 1 doesn't affect the 8, it has to be 5 or more. Well, that's it for task 300, Pythagoras' theorem, the square on the long side. So the square on the long side is equal to the squares on the other two when you add them together. You've always got to look for where the long side is, so that when you get to questions like these ones, you know you're not just going to add and square root, you've got to set up the equation right. It's the long side squared is the other two squared and added together. So the long side squared, those two added together. Okay? That's it. Good luck. See what you can do. Where's the off button?